Applications of quadratic equations. We have certainly worked with application problems already in the course. We know that we want to begin by completely reading the problem, having a clear understanding what information we have to work with, and also completely understand what the problem is asking us to find. Then come up with a plan in order to solve the problem, which of course is going to involve solving or setting up an equation. In this case, it's going to be a quadratic equation. So solve the quadratic equation once you set it up, making sure the answer seems reasonable and that you completely answer the question. So the first type of application problem is a consecutive integer problem. In these problems, you might be asked to find 2, 3, 4, even maybe more consecutive integers. It could be simply consecutive integers or consecutive odd integers, consecutive even integers, whatever the case may be. So in the first example, 2 consecutive odd positive integers. So the overall concept, we have 2 unknown numbers, so that's the way we're going to set it up. We need a starting place. So the first unknown number is simply going to be x, our starting point. Now if the first unknown integer is x, the next consecutive odd integer must be x plus 2. If it was just consecutive integer, we would set it up as x plus 1, but it's a consecutive odd integer. Therefore, x is going to be an odd number, so we need to jump over the even number to get to the next odd number, so we simply add 2 to it. So we have our 2 unknown values set up, x and x plus 2. If we read on, the keyword product says if we multiply these two numbers together, that's going to be equal to 399. So we already have an equation set up. Of course, simplify a little bit, distribute that x, setting it equal to 0, we see that it's going to be a quadratic equation. So solve by factoring x minus 19 times x plus 21. Set each factor that has a variable equal to 0, x is equal to 19, and x is equal to negative 21. So we solved the quadratic, came up with two numbers like we do typically when we solve a quadratic equation, and the problem was asking us to find two numbers. But these are not the two numbers that the problem was asking us to find. These are just two possible values for x, and x, if you recall, was simply the first unknown number. So we have to make sure they seem reasonable. Now the problem stipulates that these unknown numbers must be positive, so therefore x cannot be equal to negative 21. So x is simply equal to 19. To find the next consecutive positive odd integer, we just substitute x equals 19 into the expression for it. 19 plus 2, of course, is 21. Now we do have two consecutive positive odd integers, 19 and 21, and if we check ourselves, multiply them together, their product is equal to 399. So we know that we have the problem correct. The next example is a geometry problem. Now we've seen geometry problems before when we're solving linear equations, so now we're going to be setting up a quadratic equation. Just involves some sort of geometric shape, in this case a rectangle, so we know a rectangle is made up of the length and the width, and in this particular case it says the length is 3 feet more than the width, so if we let the width remain represented by the variable w, the length then will be the width plus 3, or w plus 3. The problem goes on to talk about the area, so you have to know the formula for area of a rectangle. Area is equal to the length times the width. And notice we're not asked to solve for the area, we're given the area of 40. So we can substitute that into the equation, along with what we set the length equal to, w plus 3, and we left the width as w. Once we simplify, we see a quadratic equation, so set it equal to 0, and solve. Factors into w plus 8, w minus 5, which gives us w is equal to negative 8 and w is equal to positive 5. Now the problem was asking for the dimensions of the rug, length and width, but we just found two possible values for the width, w. Have to make sure they seem reasonable. Well, of course, the width cannot be a negative number, so we have to get rid of it. 5 is the only reasonable answer. So if the width is equal to 5, that means the length is going to be 3 feet longer, or 8 feet. So take a quick check. We have dimensions of a rectangle where the length is 3 feet longer than the width. And if you multiply them together, the area of a rectangle, 5 foot by 8 foot, would be equal to 40 square feet. Next example is just a general application problem. Understand what's going on. Overall concept, we have two unknown numbers. So once again, we're going to set up the two numbers here based on what we know about them, how they're related. We know the first is just a positive number, so x. The other one is going to be a number 6 less than twice that number. So twice that number, first of all, you multiply it by 2, 6 less, subtract 6 from it. So we have our two unknown numbers set up. Pick up on the keyword product, which means we're multiplying together, so x times 2x minus 6, which is going to be equal to 140. We simplify. See, it's a quadratic equation, so put it in standard form, set it equal to 0, and factor. Greatest common factor 2. Continue on factoring x minus 10, x plus 7. So 3 factors, we only set the factors that have a variable equal to 0. X minus 10 is equal to 0, x plus 7 is equal to 0, which gives us x is equal to 10, and x is equal to negative 7. Two numbers, or two possible values for just x, which was the first number. Now the problem specifies these have to be positive numbers, so that negative 7 doesn't work. So the first unknown number, x is equal to 10, which makes the next unknown number 2 times 10 minus 6, gives us 20 minus 6, or 14. So we have two positive numbers. One is 6 less than twice the other, and their product is equal to 140. So we know we have the problem correct.